Welcome to Lesson Overview 3.05, Chords and Arcs, where we will describe the relationship between chords and arcs, describe the relationship between the measure of a minor arc and the measure of its central angle, and solve problems using relationships between chords and arcs. A chord connects to any 2 points on a circle. In circle T, TX, TW, TZ, and TV are radii. XV is a diameter, and XY and XV are chords. Notice XV is a chord and a diameter. A diameter is a chord that passes through the center of a circle. All diameters are chords, but not all chords are diameters. An arc is a set of points on a circle between 2 points on a circle. A semicircle is an arc with endpoints that are also the endpoints of a diameter. Minor arcs are arcs smaller than a semicircle, and major arcs are larger than a semicircle. In circle C, AB is a minor arc, which also could be named arc BA, written like this. To describe the larger arc that has endpoints AB, the major arc that goes around the other way, we would write arc ADB or BEA. Two semicircles in circle C are DAB and DEB. A central angle is an angle that has a vertex at the center of the circle and its sides as radii of the circle. An inscribed angle is an angle that has its vertex on a circle and its sides are chords of the circle. In circle T, XTW, angle XTZ, angle WTZ, angle WTV, and angle ZTV are central angles. NWVXY is an inscribed angle. An arc is a part of a circle that is formed by 2 points on a circle, and all the points of the circle that lie between the 2 points. There are 3 sizes of arcs: a semicircle, which measures 180 degrees, minor arcs, which are less than 180 degrees, and major arcs, which are greater than 180 degrees. A semicircle is an arc whose endpoints are also the endpoints of a diameter. A semicircle is named by its 2 endpoints and any point on the circle in between. It doesn't matter which endpoint is named first, but in between points must be placed between the 2 points. For example, in this circle, LJM is the name of a semicircle. That semicircle could also be named MJL, LGM, or MGL. An arc that is smaller than a semicircle is called a minor arc. A minor arc is named by its 2 endpoints, GJ. GJ is a minor arc. An arc that is larger than a semicircle is called a major arc. A major arc is named by its 2 endpoints and 1 endpoint in between. GNM is an example of a major arc. So is GKJ. You can place chords, including diameters and radii, on a circle so that they create angles. If the angle has its vertex at the center of the circle, then it is called a central angle. Angle LPN and angle NPM are both central angles. If the vertex of the angle on the circle, then the angle is called an inscribed angle. Notice the vertex L is on the circle. Angle SLM is an inscribed angle. The degree measure of a minor arc is the measure of its central angle. The degree measure of a major arc is 360 degrees minus the degree measure of the central angle of the minor arc. The degree measure of a semicircle is 180 degrees. Two circles are congruent if they have the same radius. Two arcs are congruent if they are on congruent circles and have the same angle measure. An arc can be defined as a continuous portion of a circle. Because a circle is curved, so is an arc. An arc can be measured in degrees as an angle is measured, as well as in linear units as a line is measured. The degree measure of an arc is the same as the degree measure of its corresponding central angle. Notice here, the measure of arc BC in blue is equal to the measure of angle BAC in red. If you draw a diameter on a circle, you have two straight angles. Each angle measures 180 degrees. If you add the measurements of the two straight angles, you get 360 degrees. Another way of looking at this is to imagine a point on the circle moving completely around the circle one time. If you could measure the degree it moved, you would see that it moved 360 degrees. For circle A, measure of angle A equals 45 degrees. Therefore, the measure of arc BC measures 45 degrees. In this example, BC is a minor arc, but suppose you want to measure the associated arc BDC in orange. We could say the whole thing measures 360 degrees, and we know that this blue part measures 45 degrees. So 360 subtract 45 is 315 degrees. Remember from an earlier lesson that the formula for calculating the circumference or the length of a circle is 2 pi r, or as we learned in class, pi d, because the diameter d is 2 times the radius. An arc is a portion of a circle, so the arc length is a portion of the circumference of the circle. The length of that portion will be a fraction of the circumference, just as the degree measure of that portion is a fraction of the degree measure of the entire circle. For example, if you have a 60-degree central angle, the corresponding arc measure is 60 degrees. That measure is a portion of the 360-degree total measure of a circle. You can set up the proportion that represents this relationship as the measure of arc JK over the measure of circle B is equal to 60 over 360. To find the length of the arc, you use the circumference of a circle, the arc's degree measure, and the radius. So if M is the measure of the arc or central angle and R is the radius, you solve the proportion shown here for L. L over 2 pi r or pi d is equal to the measure over 360. The length is the measure divided by 360 times 2 pi r or pi d. Let's determine the measure of xy, then determine the measure of yzx. Angle XOY is a central angle whose degree measure is 145 degrees. XY is the arc intercepted by the central angle XOY. Because the degree measure of a minor arc is the measure of its central angle, then XY measures 145 degrees. We can take 145 degrees and subtract it from 360 to find that YZX measures 215 degrees. Let's determine the length of AB. This time we're going to use 3.14 for pi. A radius of a circle joins the center of the circle to the point on the circle. Angle AOB is a central angle whose degree measure is 60 degrees. Arc AB is the arc intercepted by the central angle. Therefore, the measure of AB is 60 degrees. AOB is 60 degrees as well. The radius is 6. The way we determine this is to set it up that length is equal to the measure divided by 360 times 2 pi r. We're going to replace pi with 3.14. 60 divided by 360 is 1/6. 2 times 3.14 times 6 is 37.68. 1/6 or 37.68 divided by 6 is approximately 6.28. Therefore, the length of arc AB is approximately 6.28 centimeters. Many relationships can be proven about circles, chords, and arcs. The following theorems are just a few of these relationships. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. In a circle or in two congruent circles, two chords are congruent if and only if they are equidistant from the center. In a circle, a radius is perpendicular to a chord if and only if it bisects the chord. Because the theorems all contain the statement if and only if, the proof of all of these theorems requires two separate proofs. For example, consider the third theorem. To prove that theorem, you would have to prove each of the following two theorems. In a circle, if a radius is perpendicular to a chord, then it bisects the chord. In a circle, if a radius bisects a chord, then it is perpendicular to the chord. Given AB is a chord of circle O, OC is the radius of circle O that bisects AB at point D. We're going to prove that OC is perpendicular to AB. Remember, if the measure of an angle is 90 degrees, then the angle is a right angle. If two lines intersect in a right angle, then the line is perpendicular. Here we're going to start out the two-column proof with our statement and our reason. Remember from previous lessons that our statement says, I know, and our reason says, because. We can say, I know AB is a chord of circle O, and line segment OC is a radius of circle O that bisects segment AB at point D because it is given. I know segment AO is congruent to BO because all radii of a circle are congruent. I know segment OD is congruent to OD because it's reflexive property of segment congruence. I know segment DA is congruent to DB because of the definition of segment bisectors. I know that triangle AOD is congruent to triangle BOD because of the side-side-side congruence postulate. I know that ODA and angle ODB are CPCTC. That stands for corresponding parts of congruent triangles that are congruent. And I know that measure of angle ODA is equal to the measure of angle ODB because of the angle congruence postulate. I also know that the measure of angle ODA plus the measure of angle ODB equals 180 degrees because of the linear pair postulate. And the measure of ODA plus the measure of OD equals 180 degrees because of substitution property of equality. Therefore, 2 times the measure of ODA equals 180 degrees, and the measure of ODA equals 90 degrees because of division property of equality. Therefore, angle OC is perpendicular to AB by definition of perpendicular lines. If you have any questions on this lesson, please reach out via text or email.